As I think you will be aware that this epidemiology, biostatistics, so all these are come, even the medical science, you can say, these all are come under the umbrella of public health. So basically, in the public health, we are dealing the mass population, means we are not dealing the individual population, or sorry, individual person for any kind of treatment or giving some intervention or for any purpose. But in medical field or in medical science, you can say that we are dealing with individual patient. When the patient are coming to the individual, we are just investigating that particular patient, and as per the finding of their measurement, we are giving some treatment. But in public health, basically we are giving, if we are going to give some intervention, so we are giving at a community level. Either if we are going in a village, so we are giving some intervention at the village level. The recent example, you can say, this uh, epidemic here, just you can say that this lockdown is a kind of intervention, because we are government are trying to stop the spreadness of the virus. So in this intervention, we are just not going to give the treatment to everyone, but the preventive measures we are also considering as a intervention. So the question is, but these, basically when we are talking at the community level, so basically the, the things, so there are many things which we want to measure, like disease frequency, prevalence, incidence. So how we will go to measure these things? So we will discuss all these here one by one. So so basically what we will cover here, the first is the we will discuss about the, means try to understand what is the epidemiology, and then for what purpose it is used, and what are the basic measures. We are not going to discuss with the advanced measure, we will discuss only the basic measures of epidemiology here. So this epidemiology is derived from the Greek words, and this made from these three words. One means EP, when you can say the EP, and EP means upon or befall. And another word is demos, means people, and the third one is logos, means study of. So the overall, the definition of epidemiology, you can say that this is the study of that which befalls people. And broadly, this definition is classified or defined by this scientist, that is John M. Last, which gives epidemiology is the study of distribution and determinant of health-related states or event in specified populations, and the application of epidemiological study is to prevent and control of health problem. So now try to understand this example. What, sorry, this definitions. So these definitions cover many things. Epidemiology is the study of distribution and determinant of health-related states. So here you can see that the, you can say, the broad definition. So study means this study may include any kind of study, like it may be a surveillance, it may be any observational study, it may be the hypothesis testing, or any analytical or experimental study. So all kind of study may come under this. And distribution refers to the time, person, place, or class of people affected. And determinants means what are the factors that are influencing the disease, or you can say the community. So that may be a biological factor or chemical factors, or maybe some physical, social, cultural, economic.
नहीं
So
अभिषेक
all
अंदर
these
रहेंगे.
are coming under the determinants. And health related states and event means it's refer to the disease or cause of death or behavior such as consumption of tobacco, means tobacco users, positive health states. So these are come under the health related state. And what is the meaning of specified population? Specified population means those who can easily identifiable, those having identifiable characteristics, such as we have written here occupational group, and the application to prevention and control. So the final aim of this epidemiological measure is to uh, prevent the individuals or population from the health related problem. So the purpose of the epidemiology is basically the first purpose. We are trying to find out the what are the cause of that disease, or what is the natural history of the disease. Causes means like, just take example, when in a village we are going to see like you can say the malaria are spreading in a village, and you are going to measure that. So we are trying to find out what are the causes due to which malaria is spreading in that area, whether the mosquito is uh, are there. But we are trying to find out the natural history, means if the mosquito is the reason, so from where this mosquito are coming. So these kind of uh, problems we are trying to find that, and then determine the frequency of the disease in the population. Means once the disease are spread in an area, so we are trying to find out their frequency, means out of the total population, how much population is affected from that disease. And then identify the pattern of disease of occurrence. Pattern means we are just analyzing different way, means whether it is affected those who are socially or economically weak, or it is or spread in everyone, or whether it is spread in particular area but other are not affected. So we are trying to find out the patterns of the disease, so that we can make accordingly our arrangement and go for the treatment. And then we are trying to find out the risk factor. What are the risk factors that are involved or involved in the disease, so that we can remove that, we can eliminate that risk factors, so that the patient can be and you can say the treated, or that can be prevent from the disease. Then evaluation of effectiveness or of preventive and treatment measure. So when we have analyzed the problems of the disease, then we are giving some preventive measures, and after some time of interval we are measuring that their evaluation, where their effectiveness of that preventive measure, whether these preventive measures are effective or not. So ultimate goal, we have already said that the ultimate goal of this epidemiology is to prevention and treatment and resulting in the preservation of public health problem. So now the investigation approach in epidemiology are basically there is descriptive approach, analytical approach, or intervention or experimental experiment, and finally the program evaluation. So descriptive approach, basically we are asking some problems from that area or from the people, in which we are asking like this: what is the problem, from where this problem, like if we are taken the example of malaria, so we are asking that from where or uh, why this problem are spreading in this area, what is the main problem, and what are the factors are involved. So this type of we are making question to do this in descriptive approach. Then in analytical approach, we are trying to analyze the cause and determinants of the disease. So whatever the informations we have collected from that area or individuals, so we are analyzing them and we are trying to associate that factor with the outcome variable. And then interventions or experimental epidemiology as a clinical or community trial to answer the question about effectiveness of the measures. So basically in this we are, whatever the intervention we are giving, we are not giving some selected people, we are giving at a community level, and we are trying to measure their effectiveness. And then finally we are evaluating that program. Means you will be aware about this the NHM program of government. So in this there are many programs are running. So at some time of interval, the government are evaluating their program for their effectiveness. Means they are measuring whether these programs are effective for the community or it is not, whether it is beneficial for those to whom this program is built, or it is not reaching to that person. So that evaluation may be this involved in many you can say that means there are many aspects of evaluation, but overall the evaluation of the program is to measure their effectiveness. Now as you are aware that uh, whenever we are formulating a problem, basically we are trying to uh, associate our exposure variable with the disease or health outcome. So this health outcome may be expressed through the multiple type of measures. So what are this epidemiological measures? In epidemiology, basically what are that measure which we are uh, using to measure this disease or health outcome? So the first and the very basic, and I hope you all will be aware to these three terms which we are using very frequently in our day-to-day life, and these are the ratio, proportion, and rate. So what is the ratio? So before coming on that, we have already discussed these things in uh, uh, in previous class. Basically, the outcome variables which we are generally measuring, all that are mostly in dichotomous nature. So now here is the general formula to measuring this ratio, proportion, and rate. So this general formula, if you have the two quantity or two your measurement, that is x, y, so we can measure all these three by using this formula. Y by x into 10 raised to the power n, where n is your rate base, that you can, if you want to compute in percentage per 100, so here this n will be 2. If you want to rate per 1000, so here n will be 3. So by this way you can measure. Now the things which we want to discuss with you, what is the ratio? Ratio, when just you imagine the above formula which we have written, general formula, x by y into 10 raised to the power n. So in this two variable x and y, one is your numerator and another is denominator. So when your numerator is not a part of denominator, then this measures this, these are the two different quantity, and when we are dividing this one by another, then we are saying this is a ratio. So it is a fractional measure in which the numerator is not part of the denominator. This is a simplest example you can consider as a sex ratio. In a population there is male and female, and but if you are dividing male by female, so we will get the sex ratio. So here your denominator and numerator both are different quantities, both are entirely different to each other. Now what is the proportion? Proportion, a fraction in which the numerator is a part of denominator. Means if, like if you take the above example, out of the total population, if you want to see the proportion of male, so male divided by the total population, that will give you a proportion. Or if you want to see the proportion of female, so you can divide this female by the total population. So this is the proportion. Means in denominator we have also involved the numerator part. Another example which we have taken, in a hospital, suppose if there are 400 male cases and 200 female cases of tuberculosis, and then if you want to measure what is the proportion of male cases among all cases, so among all cases means 400 plus 200, that will be 600. So the proportion of male cases, 400 divided by 600. So this is the your proportion. Now what is the rate? Rate is a measure of occurrence of some specific event in a population during a given time period. So here time factor is involved. So means we are measuring, like just you can understand through this example in which we have taken, suppose mortality rate of a tetanus in a country X in 2017 are given. So the total death due to tetanus is 17, and population of that countries is suppose 58 million. So your mortality rate will be that uh, tetanus death in this 1 year period. So here time factor is involved. So the total number of death in 1 year divided by the total population within that period into 1000 if you want to uh, estimate per 1000 mortality. So this is your rate. Now here population at risk, actually we want to discuss because we will use this term population at risk in in upcoming slides. So we want to discuss here what is the meaning of this population at risk. So population at risk means, suppose if we want to calculate the prevalence of anemia among reproductive age group women in India in year 2011. So what will be the population at risk? So the population at risk will be only the women or those women which will come in this reproductive age group. So how you will get, we have divided this whole population of India in two parts, male and female. We will consider only female population. We cannot consider male population because male are not going to take part in a reproductive process. So the first we have separated the male population. Then this female population we have divided in less than the period which come less than start of the reproductive period and also above the reproductive period. So we have considered only this 15 to 49 year of age is your reproductive period. So this is the population which we can say that this is population at risk. Now you will also be aware, most of you will be aware to these terms, that prevalence rate, incidence, case fatality, and mortality rates. So now what is the prevalence? So prevalence is your just you can say the frequency of existing cases in a defined population at given point in time. So here basically in numerators we have taken the number of people with disease or in a specified time period, and your denominator will be the total population, you can say the number of people in the population at risk in the specified population, specified time, not population. So basically you can say the number of this existing cases divided by that total population which is at in that specified time into 1000. Generally we are taking 1000 because, or 100, basically prevalence we are measuring in 100, which we are generally we are using percentage in our day-to-day life. So here we have taken a simple example. The measurement of diabetes was taken in a population of 40,000 people. So in this population, if finally 2,000 people has diagnosed with diabetes, then what will be the prevalence? So prevalence will be the number of people diagnosed with the disease is 2,000, and the total population of that area in that specified time is 40,000. So that 2,000 divided by 40,000 will be your prevalence. This comes 0.05. If you will convert in percentage, multiply by 100, you will get 5% of the total population. So it means out of this total population, 5% population is affected from the diabetes. Now this prevalence is divided in these three categories. You can say the point prevalence rate, period prevalence rate, and the lifetime prevalence. So you can better understand from these examples here. Point prevalence means at any point of time, what are what are those people which are affected from that disease. So if you consider this point 11 2009 is your this point, so at this point you can see in this example this cases number 2, 4 and 5 are affected from that disease. Similarly, in this point time, you can say the 6, 7 and 10 are the number which are coming at this point. And when we are talking the period prevalence, if you are talking about these two period, so the number of cases will be 2, 3, 4, 5, 6, 7, 9 and 10. And the lifetime prevalence means if the disease are coming any point of time in your lifespan, then you can consider it as a lifetime prevalence. So now these are the some sorry. Yeah, these are the some factors which influencing your prevalence. So prevalence, you can see here what are the factors that are involved by to increase the prevalence. That is your longer duration of disease, prolongation of life of patient without cure, increase in new cases, in migration, out migration of healthy people. So these are the some factors which influence to increase your prevalence. And similarly, just opposite to this, you can say the shorter duration of the disease, high case fatality rate among the disease or from disease, decrease in new cases or in migration of the healthy people or out migration of the cases or improved cure rate of the cases. So these are the some factors which are influencing our prevalence for decreasing and increasing. Now, what is the incidence? Incidence basically just in the your numerator, we are considering only the new cases. The difference in prevalence and incidence is this. In incidence, we are considering only, in numerator, we are considering the new cases. The others things are remaining the same. So incidence of disease represents the rate of occurrence of new cases arising in a given period in a specified population. So here we have taken example in a study of 10,000 women cases is greater than 15 years and who do not have been breast cancer at the beginning of the study period. Over the course of 1 year period from 1st January 2015 to this 31st December 15, suppose if 10 women were diagnosed with the breast cancer. So in this case, what will be your incidence? So incidence will be what you this 10 divided by this total population of this 10,000. Now, instead of using this above formula of incidence, nowadays we are using these two, that is incidence rate, or we can also say the incidence density and or cumulative incidence. And these are more, you can say, correct definition instead of measuring through this the above which we have discussed here. So in this incidence rate, basically in this your numerator. So first we have to understand what we are actually doing. So each person in the study, suppose if you have selected some patient and you want to measure their this incidence rate. So at the time of beginning of the study, suppose if each person are disease free, and you are going to follow them with some up to some years, you can say the 5 year 6 year, depending on your study period. So at the time of beginning, we are considering all that individual are, suppose if they are healthy. So each year that individual, each year they are contributing a 1 year, 1% year. Means if we are that person are remaining 1 year till 1 year, if it is disease free, then it contributing in denominator is 1% year. If that person is coming up to the 2 year is disease free, so is contributing 2% year. So basically in the denominator, we are counting the sum of all the disease free person time period of all that study population. And in the numerator, we are taking the new cases which we have taken in the earlier case. So the numerator is strictly referred to the only first event of the disease. The unit of incidence rate must be include the unit of time. Means the cases per 100, per 1,000, or per day, per week, per month. Means unit of time, not per 1,000. Actually, it will be this. So the example which we are basically taking, you can see from this slide. Here we have taken this 7 individual and we have followed them, all of them, till 7 years. So the first person, you can see here, from their beginning to the end of this 7 year, these are remaining diseases free. The second person also remain disease free. So these are contributing 7% year in the denominator. Similarly, in the third case, you can see that up to the 2 year, it was remain disease free, and then the person is diagnosed with some disease. And then up to the 5 year, it was with the disease, and then the person has died. The fourth person is remain disease free till 7 year. Similarly, the fifth person up to 3 year it was disease free, and then last to follow. Sixth person up to 2 it was disease free, and after that it was with disease. Similarly, the second person up to 5 year. So all that period in the right hand side you can see here we have written all the period of each individual in which they are remaining disease free. So the addition of this disease free time period is coming in your denominator. So if you will add this, you will get this 33. And in the numerator, we are saying we are considering only the new event which are occurring in that period. So how many new cases is there? 1, 2, and 3. So your incidence of the disease or incidence of rate of disease will be this 3 by 33. So this is your actual, you can see this is your incidence rate of the for this case. So if you divide this, you will get and if you multiply it by 100, you will get 9.1 cases per 100% year. Similarly, you can get the cumulative incidence. So in the cumulative incidence, in numerator is your number of those who get a disease during a specified period divided by the number of people disease free of the disease in the population at risk at the beginning of the study. So at the beginning of the study, you can see here all the individual are disease free. So in the denominator it will be 7, while in the your numerator it will be 3, the number of cases. So cumulative incidence will be your this 3 by 7. So if you calculate in per 100, so 43 cases per 1000% during this 7 year. So this will be your cumulative incidence. So this in a statistical sense, this cumulative incidence is the probability that individual in the population or get the disease during the specified period. Now this is the difference between incidence and prevalence. So you will read that. I'm going to skip this. Now the case fatality. In the case fatality, your numerator is the number of death from diagnosed cases in the given period divided by the number of diagnosed cases of the disease in the same period. So in the previous example, you can see that the number of death here is 1 and the total cases, diagnosed cases is 3. So case fatality will be this 1 by 3 means 33% representing 1 death out of 3 diagnosed cases. So this is your case fatality. So I'm skipping this also, the relationship between interrelationship between prevalence and incidence. Now come on the crude birth rate. So basically, crude birth rate is basically you can say the total number of live births per thousand population in a given year. This is called crude birth rate. So as a formula, you can say the number of total live birth divided by the total population at mid-year into 1000. So it's give you the crude birth rate. And why it is called crude? Because this is called crude because in the denominator we are considering the total population. Means we are also considering here the male and female, child, older, all people we are considering in denominator. So as we know, the male population are not going to take part of in this birth process. So because of this, we are saying this is a crude birth rate. Similarly, you can measure the crude death rate. So this is also giving you the total number of death per thousand population in a year. So your numerator will be number of deaths divided by this total population. So this gives you crude death rate. And when we are just subtracting crude, if your crude birth rate is higher than death rate, it means our population is going to increase. And if death rate is higher than crude birth rate, then our population will be going to decline. So growth rate you can calculate by subtracting this crude birth rate minus crude death rate. Now come on the age specific death rate. So age specific death rate, why we are calculating this age specific death rate? Because we know that in every age group the death rate are different. At the time of birth the chances of death is higher. So as the age of the individual is increasing, the chances of death is reduces. And at the last means when they are going plus 80 years, so chances of death will also again go high. So means every the age group has different mortality. So because of this, we are calculating this age specific death rate so that we can compare between them easily and we can make plan accordingly. Because if you know that the neonatal death is high, then you can make plan accordingly how to prevent them, and we can how can you can prevent them, and you can make a specific treatment plan for that age group. So because of these reason we are just calculating age specific death rate. So this age specific, in this your numerator is the number of death in 1 year for person in a given age group divided by the number of person in age group at mid-year. So the conventionally we are taking this age group like 0, 1 to 4, 5 to 9. So basically the 5-year interval we are considering, but we can also calculate as per our requirement or as per our desire. So here we have taken the example. So we can say this is the age group and this is the total population in this age group and the death which are coming in this age group. So age specific death rate will be this death divided by this population into 1000. So this will give you age specific death rate. So CDR will be your this total population. If a total death divided by this total population, this will give you CDR, crude death rate. Now come on standardized death rate. So standardized death rate basically we are we are to make comparable, we are doing standardization because we want to make comparable that death rates. So because of this property, comparable property, we are saying we are converting our death rate, calculating death rate through this standardized death rate measure. So there are two methods of standardization. One is the direct standardization method, and another is indirect standardization. So this is the formula. I will not go on that. Just I'm taking this example to explain you. Suppose if you have these two population, A and B, and you know this age group and their mid-year population and death rate for these two population, and you want to compare the death rate of these two population. So if you calculate the simply crude death rate, so how you will get that? This total death divided by this total population, this will give you crude death rate. Similarly, you can calculate for the population B, the total death divided by the total population, you will get death rate. So when we are comparing these two death rate, we found that the population B has higher death rate as compared to population A. Now the question is whether we can compare this way, whether this is a good way to compare the death rate of these two population, or we can do some another way which will be more representative. So to make them comparison, actually we cannot compare directly because the population from where we have taken this population, there may be due to some specific reason, like if we want to compare the Kerala and UP or Mumbai or UP, so you will find that the situation of these two populations are different. Like in the present COVID scenario, you can see that the Mumbai has the highest number of cases and death is also higher there. So if you are going to compare in between these two population, so it may be possible that we cannot easily compare because of their demographic or there some other factors, are both are different. So for this we are taking we are doing standardization of this population. So suppose for this example, instead of taking this population of population A and B, we are filling here the standard population. Means if you are taking the national average of the population which are coming between these age group. So here you can see that we have taken the reference population per thousand in this age group from the national average. So national average generally we are considering that this will be representative to the all state. Agar if you are talking about the in the sense in the Indian context, so we can say that this will be representative for all state. So because of this we have taken the standard population. So now we know that age specific death rate from these population A and B. So by using this age specific population, we can calculate the expected death of these two population. So by using this age specific death rate for of the population A and population B on standard population, we can calculate this expected death. Now you can calculate from this population your crude death rate. So add this total death divided by this total population. This will give you the crude death for A and for this population for B. So now you can make a comparison. Now here you can see in this example, when we are comparing this adjusted death rate for population A, we are getting 23.3 per thousand death rate. While in the for the population B, we are getting 22.7 per thousand population death. So now you can see here, when we have calculated here, we found that the population B has higher death rate. But after standardization, we found that the population A has higher death rate as compared to this population B. So for this, we are just making this standardized, we are calculating the standardized death rate. Now this is the indirect method. So I'm not going that. Now infant mortality rate, you all will be aware. The infant we are considering the person is age less than 1 year. So the number of infant death divided by total live birth of that 1 year into 1000. So it will give you infant mortality rate. Similarly, you can calculate child mortality. So here from this chart, you can easily understand the early neonatal death is 0 to 7 days. Similarly, postnatal is 20 years to 40 days. Neonatal is 0 to 20 years days. So by this you can use this same formula. Only this your death, number of death in this period which we have mentioned here, only this will change, and this population live birth will be counted in between this period. So by this way you can calculate all this death, child mortality. Now the MMR is basically the maternal death which occurred due to pregnancy related causes or childbearing causes. So we are saying that this is the maternal mortality ratio. The formula of this MMR is number of maternal death divided by the total live birth in this period, like in 1 year, into, generally we are calculating per 1 lakh population how many maternal deaths are occurring. We are going to skip some of the slides. Now come on here, a relative risk. We have also already discussed in the previous class some aspect. So your relative risk is the ratio of risk of occurrence of disease among exposed people to that among the unexposed people. So ratio of risk we have already discussed in the previous class. So this is the risk in exposed divided by the risk in non-exposed, and this risk ratio is also called is relative risk. So you can also calculate this in terms of incidence. So incidence rate among exposed divided by the incidence rate among non-exposed will give you the relative risk. Now this is one examples which we have taken. This is a cohort study, and here we have also started discuss to cross two table. So in this here we have taken exposed and non-exposed group, and here the disease develop and disease does not develop. So if we have written this A, B, C, D, and the total of this exposed is A plus B and total of non-exposed is A, C plus D. So incidence in exposed will be this A by A plus B. This will give you incidence in exposed group. Similarly, you can calculate incidence rate in non-exposed. So this will be C by C plus D. And when you will take ratio of these two, this will give you a relative risk. So here is the example. So what is the interpretation of this? If this risk, relative risk is coming 1, so it means the risk in exposed and non-exposed group are equal. Or you can say there is no association in these two, means risk in exposed and risk in non-exposed. And if your relative risk is greater than 1, so it means risk in exposed is greater than the risk in non-exposed. Or you can say this is a positively associated. And if is less than 1, means the exposed risk in exposed is less than the risk in non-exposed, or you can say the negatively associated. The odds ratio, which I have already discussed this in
Sir, sorry to
previous
interrupt.
class.
Sir,
So this odds ratio is basically the probability that the event will occur to the probability that the event will not occur. So
sir,
again,
sorry
if
to
you
interrupt.
take this 2 by 2 table, so the odds in exposed group, that will be A by A plus B, and odds in non-exposed group, it will be C by D. So if you take the ratio of these two odds, you will get the odds ratio. You can see here. And the interpretation of this odds ratio here, if the odds ratio is equal to 1, then exposure is not related to disease, and if it is greater than 1, then exposure is positively related to the disease, and if it is less than 1, means exposure is negatively related to the disease. So this is the overview of the measurement of this epidemiology. So you can see here. Now this is all about the today class. Now if you have any query, you can send. And one more thing which I want to say, you check your email